Let's see how you did. If there were 13 atoms before, will there be 13 atoms after? Yes. If there are 20 of one type, let's call them like squares. 30 of another type, let's call them circles. How many atoms will be present after the reaction? Remember, you don't lose any of them. So if you have 20 and 30 on the left, you're going to have 20 and 30 on the right, which is 50. So if 20 atoms weigh 2 grams, so these guys weighed 2 grams, and if 30 atoms right here weighed 3 grams, what will be the mass after the reaction? So what we're saying is that on the left side, we have 20 atoms, and we know they weigh 2 grams. We have 30 atoms, and they weigh 3 grams. I don't lose any atoms. They just rearrange themselves. So if I don't lose any atoms and they all, add up to the same mass, then that means the mass on the left side is 5 grams total, and the mass on the right is 5 grams. And then if 300 atoms of liquid water are boiled, how many atoms of water are now gas in the air? So if they all boiled, then now they're just 300 atoms in the air. Now this section is just some terminology, making sure you're really comfortable with terminology. We have pure substances and we have mixtures. So pure substances, mixtures. So pure substance is composed of a single element or single compound throughout. Now, what this means is it's a single type of element. It can be lots of elements, but they're all the same type. So say they're all, in a minute, we'll see gold atoms. And up here, the single type of compound throughout. So we have our 2 categories. We have our element right here. Cannot be broken further without breaking the atoms. So you get down to gold. If you start trying to break gold down any further, you're going to break up the nucleus and really mess it up. And then you have compounds. So compounds is, again, it has to do with just elements, and there's only one type. So this is table salt. This looks really familiar. Table salt, NaCl. It only has NaCl stuck together like that throughout, if it's pure. Only NaCls, and there's no water in there. There's no, black specks of randomness. There's no pepper in there. This is just NaCl stuck together like that in the salt. So those are both examples of pure substances. The left, just gold. The right, just NaCls. Then we have mixtures. This is very common. Mixtures have a composition of more than one type. So you've got 2. You've got heterogeneous, hetero, different, homogeneous, same. So heterogeneous is when the composition is inconsistent and they're not mixed evenly. So if you took a bite or a little bit of one flavor in your mouth one time, you might have a little bit of another flavor, just a little bit different the next time. So you've got oil and seasonings and water. All of those mixed together. And so you can see, if you got this section right here, it would have a different amount of oil and things compared to if you grabbed that section. That's the idea of an inconsistent composition. It's got all kinds of things. It could even have salt in here and pepper and tons of other things. Compare that to homogeneous. So this, again, has more than one type of thing in it, but they're all mixed. They're all dissolved equally. So if you take this section, it looks exactly the same as this section. So again, they have a consistent composition and an inconsistent. We'll do some example of these in just a second. This is a flowchart. If you like flowcharts, working through information, this is great. So again, does it have a constant properties and composition? And if you say yes, then you're looking at something's pure. It doesn't have anything else added to it. Can it be simplified? If it can, then it's a compound. So a compound like NaCl, you can break it apart into Na, and you could break it in Cls. But an element like just Na, you can't break it any further. And then you say, is it a mixture? Is it uniform throughout? If it is uniform throughout, then it's homogeneous. And if it is not uniform throughout, then it's heterogeneous. So go ahead and answer these questions.